This lesson is on multiplying radicals, and it's exactly what it sounds like. You just multiply whatever's on the inside or possibly the outside of the radicals together. Whenever you're multiplying, you don't have to have the same number within the radical symbol. You just multiply that number together and put a radical symbol around it. So in the first example, to start out easy, I have the square root of 4 times the square root of 4. So I make my radical, and it's like saying 4 times 4, all under one square root. So 4 times 4 is 16, and the square root of 16 is a perfect square, so my final answer is 4. What I want you to notice is since I multiplied the same number by itself within the radical symbols, they just canceled each other out because I was left with 4 at the end. So no matter what number I pick, if I did radical 6 times radical 6, your answer is just 6. But it is nice to see this work, and I need to see the work for your homework. So you understand and I understand that you see why perfect squares are created or how you simplify them. Now, if I'm looking at the next one, I'm multiplying the square root of 3 times the square root of 8. So I'm saying 3 times 8 under the radical, and 3 times 8 is equal to 24. Now you still have to focus on simplifying from the last few videos I showed you, because some multiplication questions will give you a radical that can be further simplified. So I see that 24 can be broken down into the square root of 4 times the square root of 6. And I know that 4 is a perfect square, and the square root of 4 is equal to 2. And 6 is not a perfect square, and even if I continue to break it down into the factors of 3 and 2, that doesn't help me because those are also not perfect squares. So we're just left with 2 times the square root of 6 as your final answer. The last question, I decided to throw in some variables just to remind you of how those are done, and I also included a term on the outside of the radical. When something's on the outside, it remains on the outside. So the 2 doesn't get multiplied to the x times 3x. So right now we have x times 3x. And once again, the 2 stays on the outside. And now we are left with 2 times the radical of 3x squared. And I want to look to see if I can break down the square root of 3, which I can't. But I see that I can break down x squared into x times x. And since x squared, you should hopefully remember, is a perfect square anyways, you can take that out of the radical, and your final answer is left with the 2 on the outside. So 2x, because x squared is a perfect square, so we can take that out, times radical 3. So with multiplication, you're just multiplying whatever is on the inside by that number. If there's a number on the outside, it stays on the outside. Just to show you another example of something that's on the outside, let's do, I don't know, let's see. Let's pick 3 radical 2 times, let's do the square root of 4. Now there's 2 ways to solve this. You can either multiply the radicals together first, which is what I'm going to do, or there's a second way. So right now 3 stays on the outside, and we're multiplying 2 times 4. And in the radical, we're now left with 3 radical 8. And I want to see if I can break 8 down within factors of a perfect square. And I know that I can break that down into 4 and 2. 4 is a perfect square. So when I take out a 2, I have to remember to multiply 3 by that 2 that I take out. So it's 3 times the 2 that I take out from the square root of 4, and then radical 2 is just left over at the end. 3 times 2 is equal to 6, and radical 2 stays the same. Do not distribute into the radical. I forgot to say that. That is not an option. These aren't parentheses or brackets. Some of you, for this question, and let's just rewrite it again in green, might have said, wait, the square root of 4 is a perfect square. Can't I simplify that first? The answer is yes, you can. You're allowed to simplify that, so we'd be left with 3 root 2 times 2. And now you're just multiplying the whole numbers together. 3 times 2 is 6, and the radical 2 is left over. And notice we got the same answer in both. I hope the multiplying is a little bit easier than simplifying, but please make sure to show all of your work for your homework and simplify all of your answers.